Hello friends, welcome to my channel. Today I am going to teach you how to interface SG90 servo motors with the Arduino. Any servo motor having three terminals. The middle one is the supply, brown one is the negative or ground, and orange one is the signal input for the servo motor. Servo motor works in the frequency of 50 Hz signal. That means when we apply a pulse of total time duration of 20 millisecond, this time is 20 millisecond. So always we apply this kind of signal to the servo. As you can see, servo motor works on the principle of PWM or pulse width modulations. When the on time is 1 millisecond, servo comes to the 0 degree. When the on time is 2 millisecond, servo comes to the 180 degree. And when the on time is a 1.5 millisecond, servo comes at the 90 degree. There are some special servo motors which can rotate up to 360 degree, that is called continuous servo motors. In next video we will be discuss about that. Servo motor basically consists of three parts: a DC geared motor, a position sensing system, and control systems. As earlier discussed, servo motor works on the principle of pulse width modulations. Here in Arduino we can see pin number 3, 5, 6, 9, 10 and 11 have a sinusoidal signal. That means these are the pins which can generate pulse width modulated signals. So we can interface very easily servo motor on these pins, and by default we will be using pin number 9 to attach the servo motor. We are connecting the supply wire with the middle one, red color, and black wire is connected to the brown wire, and signal pin is connected to the yellow wire, so that we can connect the other end to the Arduino board. So these are the pins. Yellow color is signal, red is positive and black is negative. Now we connect positive terminal of the servo motor to the 5 volt of the Arduino and negative terminal of the servo motor to any of the ground terminal, and the signal pin can be connected to any of the PWM input pins or PWM output pins, but here we are connecting to pin number 9. So our physical connection is over. Now let's do for the programming. So we have attached our Arduino board with the laptop using the USB port. So let's start the programming. The first step to add the header file called servo.h in our Arduino program. So we have added the header file. Also we need to add the variable for the Arduino to servo control. Now we declare a variable which holds the angle of the servo. Here we can make the initial angle equal to 0. So this POS variable will hold the angle of the servo. Though we have attached the servo motor signal pin to pin number 9, so we have to set up the myservo.attach pin equal to 9. If you have used any other pins, you can configure as required. Now we write the body of the program. This is the basic and most important instruction for servo, that is myservo.write POS. Whenever this instruction executes, the servo motor comes to the particular angle depending upon the value of the variable. Here we have made POS equal to 0. So while executing this program, servo motor will come to the 0 degree. That's all for the program. Now let's dump the program and see the output. So till now I have not dumped the program. Now I'll dump the program while POS value is 0 degree. So it could come to the 0 degree. So I have dumped the program or dump. Now see it comes to the 0 degree. Now if I change the value from 0 to 90 and let's see what happens. I have changed the value from 0 to 90 and now again I will dump the program and see how the value is coming. Now it's come to the 90 degree. Now if I change the value from 90 to 180 degree, let's come to 180 degree. So we have seen by changing the value of POS, we can bring the shaft of the servo motor to any degree. In next phase of programming, suppose we want to scan the shaft from 0 degree to 180 degree continuously. That means from this position to this position continuously like that. If we want to scan the servo motor, so let's write the program. To move the servo shaft from 0 to 180 degree continuously, we need to use some loop and we need to use a variable. Here we are using I as a variable which will hold the particular angle, and we are using for loop to vary the value of I from 0 to 180 in a steps of 1 degree. And the value of I we have print in this. So initially I will be 1, 2, 3, 4 like that. It will go up to 180. So it will scan the entire things. Let's dump the program and see the response. Now let's dump the program and see the response. So we are dumping the program. As you can see, the motor is not moving up to 0 to 180. It is moving between some angle. It is because we have not introduced any delay between this. So electrical signal are moving very fastly. Electrical signal is moving very fastly, but mechanical system are not able to respond that fast. So that to avoid this problem, we need to give some delay between the two consecutive signals. So let's apply a delay in that. So let's apply a 10 millisecond delay and let's dump the program again and see the response. Now see, it is moving entire 0 to 180 degree. Now the rate of change of input signal and mechanical system are synchronized. Now another observation can be made. While coming from 0 degree, it is coming smoothly, but while returning, it is going suddenly, because we have not given any loop for 180 to 0 degree. We have given only the loop for 0 to 180, but we have not given any loop for coming back from 180 to 0. So let's introduce the return loop also. So we'll copy the entire for loop and we'll paste it in next. Here only changes will be made. Initial will be 180. It will be greater than equal to, not less than equal to, greater than or equal to 0 degree, and here will be I minus minus. That's all the changes. Now let's dump the program and see whether that problem is solved or not. As you can see, it was the earlier program. Now we are going to dump the program and let's see whether the problem is going to solve or not. This dumping program, it is uploaded now. Now you can see coming from 0 to 180, and 180 to 0 returning also in a smooth manner. So these are the some small experiment you can do with the XG90. You can bring to a particular angle. You can scan from 0 to 180, 90 to 180, any angle between whatever you required. So this is all about the XG90 basic experimental program. Though SG90 is a very small power consumption servo motor, so we can connect directly to the Arduino. But in future, when we will be using some advanced programming and high torque motor, we will be using that time. We cannot give power supply from directly from the Arduino. We need to use the extra power supply to power up this servo motor. So hope you have enjoyed the video. Thank you for watching.